So question now, we want to solve the inequality x plus 6 divided by x minus 1 is greater than 0. So notice how, again, this is a rational inequality. So the strategy is a little bit different. But just kind of cut to the chase here, what we want to do to solve this inequality is we want to find the zeros and the domain exclusion. So to find the zero, what we do is we set the numerator equal to 0, and we solve for x there. So if we set x plus 6 equal to 0 and solve for x, we get x equals -6. So remember, that's the 0. But since we're greater than 0, we can't include it anyway, because if it's greater than or equal to 0, then that would be part of the answer. But it's not, since it's greater than 0. To find the domain exclusion, what we do is we set the denominator equal to 0. So we set x minus 1 equal to 0 and solve for x. We get x equals 1. So it's going to be the domain restriction or domain exclusion. So what we want to do from there is we want to identify the intervals that meet the conditions of this inequality. To do that, what we want to do is place these on the number line. So -6 would be to the left, and the 1 would be to the right. And again, we do not include either one of these in the solution, so those are open-ended. Now, the easiest way to test the intervals is just, since these are integers, the table will work just fine on our calculator. So if we go y equals and clear off the previous rational function and put in, again, in parentheses, this x plus 6, close parenthesis, and then if we divide that by x plus 1, or I'm sorry, x minus 1, that looks good. If we now go to the table, we can kind of test intervals. So if we go left to -6, so if I find -6 on here, notice that if we go left to -6, we're getting positive values again. And notice how, again, we are approaching this horizontal asymptote of 1, it looks like, again, if we were looking at the graph. So we're kind of seeing over here, it's going to be positive. So if we look between -6 and 1, so if I'm now between -6 and 1, notice that the y values were, let's see here, -6, so -5, -4, -3. Notice that those y values were all negative. So that means that the graph actually drops below the x-axis here. So I'm not going to really draw the graph, because since it's a rational function, it looks kind of wonky. I'm just going to put the signs here. And then if I go right of 1, notice how, again, 1 is a domain restriction. But if you go right of 1, notice how we do get some y values. And it looks like it kind of starts to approach 1 again on this side as well. So it doesn't really take off too far. But notice how they are positive. So again, notice how we were greater than 0 up here. So that means this is a positive number. So where it's positive would be left to -6. So as far as our solution goes, we're being between -infinity and -6 in union with 1 to infinity. That's where it's positive. So that would be the two intervals that we'd be using here. So we do need to express that using the union symbol there. Again, if I look at it from the graph perspective, notice how you can kind of see the 0 is happening over here somewhere. Remember, I changed my scale as well. So remember, the window, the x scale is going by 2s. So this is like 2, 4, 6, actually. So there's that -6. Notice that's where, notice how it was above the x-axis and then it drops below the x-axis. But notice how when you get to this 1, that's where that vertical asymptote was. And once you get to 1, you can't touch 1. But once you go past 1, notice that the graph actually starts to appear above the x-axis. And then notice how it starts to approach that horizontal asymptote, which was 1. But it's going to stay above. So it's still going to be all positive over here to the right of 1. And that's kind of what we're seeing over here as well in our intervals. So I don't necessarily have to draw the graph behavior. Just understand that these represent the values of what happens when you put x in. And these are the solutions to that they're positive. Those solutions would be negative. This would be positive. And again, we're looking for greater than zero, so we're looking for positive solutions.